Beloved students, welcome to Chapter 7 Evaporation and Transpiration Basics 1. Like humidity, I would like to cover evaporation and transpiration in only one class of basics. So, as usual, let us start our class with a small, of course, inspiring story. This is the story which I always like to remember. What is that? It is tree and grass. Tree and grass. A very large tree was uprooted by the wind and thrown across a stream. The tree fell among grass, which it addressed, the tree addressed to the grasses, okay, on which it fell near the stream. I wonder how you grasses who are so light and weak, are not crushed by these strong winds. Immediately the grasses replied, "My dear tree, you fight, you contend, you fight, you contend, you fight, you contend with the wind, which are very strong, and consequently you are destroyed and thrown adjacent to us, while we, so light, so weak, so light, so weak, and so light and so weak, on the contrary, bend before those strong winds, and therefore remain unbroken and escape. To survive ourselves, we should escape. We should not be broken. Okay? So, this is the major difference between you, very big tree, and very weak and light grasses we are. Now, what is the morale? Bend in a sportive way to conquer. A wrestler or a boxer bends in a sportive way. Okay, just to win or to conquer, you should bend in a very sportive way, the way in which any boxer does. So always it is one of the stories that inspires me. Even though it's a very small, there's a great meaning in it. Is it good? No. So let's go to chapter 7, evaporation and transpiration. It is a very interesting. Just I give you what is the definition of evaporation, like other weather elements, solar radiation, air temperature, soil temperature, humidity, pressure, wind. Here also we discuss the importance of evaporation on croplands, importance of transpiration for croplands, factors affecting the evaporation, factors affecting the transpiration, small evaporation terminology, and finally units. In a single class, I just try to enlighten. The evaporation is defined as a physical process in which liquid water is converted into its vapor. Evaporation is defined as a physical process in which liquid water is converted into its vapor. The sun is the source of energy that activates the hydrological cycle, that is, the heat required for evaporation is supplied by the sun. The moisture in the atmosphere is supplied by evaporation. In this process, the molecules of water having sufficient kinetic energy to overcome the attractive forces tending to hold them within the body of the liquid water are projected through the water surface. This is the smallest possible introduction to evaporation, which is a physical process in which the liquid water is converted into its vapor. Now, what is the importance of evaporation on cropland? As I said a half minute back, evaporation is an important process of hydrological cycle triggered by the source of energy from the sun. Hydrological cycle triggered by the source of energy from the sun. So the evaporation from the soil is an important factor in deciding the irrigation water requirements of any crop. In modifying the microclimate of a crop, the evaporation from the soil is an important factor for scientific considerations. Evaporation is the most important of all the factors in the heat budget of solar radiation. The evaporation is also one of the most important factors in water economy. Of course, since a certain amount of water vapor also determines a definite amount of heat, it provides a link between water budget and heat budget. So this is in very simple terms the importance of evaporation on cropland. What are the factors affecting the evaporation? The factors affecting the evaporation are broadly grouped into two: environmental factors, water factors. The evaporation losses from a fully exposed water surface are essentially functions of these two factors: environmental factors, water factors. As far as the environmental factors are concerned, water temperature itself, wind, of course, relative humidity and pressure. Now, in environmental factors, first we discuss water temperature, how it affects the evaporation. Within an increase of temperature, the kinetic energy of water molecules increases and surface tension decreases. So, the rate of evaporation increases with a rise in the temperature. It is because with an increase of temperature, the kinetic energy of water molecules increases and surface tension automatically decreases. So, the rate of evaporation increases with rise in temperature. Of course, the maximum amount of water vapor that can exist in any given space is a function of temperature. Now, second thing is the wind. The evaporation from a fully exposed surface is directly proportional to the velocity of wind and vice versa. That means more the wind speed, more the evaporation. It is because the dry wind replaces the moist air near the water surface which is directly exposed. Okay. When there is a supply of energy to provide latent heat of evaporation, okay, this process occurs. After water temperature and wind, the third environmental factor is relative humidity. In the humidity chapter, I have already discussed where humidity is more, or on earth surface where humid conditions exist, there the evaporation are usually less. So, relative humidity, it is a mechanism that exists to remove the water vapor above the surface so that the vapor pressure of the water vapor in the moist layer adjacent to the liquid surface is less than the saturated vapor pressure of the liquid. That is the vertical gradient of vapor pressure, we call it as. When the air above water is dry or has low relative humidity, the evaporation will be greater than when air has high relative humidity over the water. In simple terms, dry air over the water surface, evaporation is more. When air has high relative humidity over the water surface, the evaporation is less. Okay. So, the fourth one is the pressure. The evaporation is more at low pressure. Evaporation is more at low pressure. As the height increases in the atmosphere, pressure decreases. Therefore, crops grown on higher elevations, they experience more evaporation. Okay, the soils experience more evaporation. So these are the factors affecting the evaporation. 1, environmental factors. 2, water factors. Environmental factors are 3, water temperature, wind, related humidity and pressure. Now let's go to water factors. 2 water factors are there: composition of water, area of evaporation. So, what is composition of water? The dissolved salts and other impurities of water decrease the rate of the evaporation. Water with impurities or salts decrease the evaporation. The evaporation is inversely proportional to the salinity of the water. The rate of evaporation from the surface of the sea is less than that of fresh water in the rivers, because dissolved salts and other impurities are more in the sea as compared to rivers. Now, the second thing about water factors is area of evaporation. It's very simple. If two volumes of water are equal in two containers, the evaporation will be greater for the one having larger exposed surface. Suppose if you take a cup and a saucer, keep same volume of water. From the cup, the evaporation is less. From the saucer, the evaporation is more, because saucer surface area is more compared to cup. Same volume of water, evaporation is more on the saucer as compared to the cup. Okay, this is how the factors affecting the evaporation can be explained in a very simple or understandable way. Now let us go to the transpiration definition. Of course, there are three different kinds of transpirations. Of course, like evaporation, we also try to understand what is the importance of transpiration of crop plants and factors affecting the transpiration. Okay, now the definition of transpiration: the loss of water from living parts of the plants is known as transpiration. The loss of water from the living parts of the plant is known or defined as transpiration. There are three kinds of transpiration: stomatal, cuticular, or lenticular. What is stomatal transpiration? This is the most common method of transpiration in all crop plants. In this kind of transpiration, water evaporates through small openings called stomata. The stomata are present on green parts of the plant, mainly leaves, of course. The stomata may present in other parts, but mainly on the green parts of the plant, or you can say leaves. The cuticular transpiration: outside the epidermal cells of a leaf, there is a thin layer called cuticle. The loss of water through cuticle is known as cuticular transpiration. The thickness of the cuticle and presence or absence of wax coating on the surface of the leaves affect the amount of water loss. Only 5 to 10% of the water transpires in cuticular transpiration kind of transpiration. So, the outside epidermal cells of a leaf has a thin layer called cuticle. The loss of water through cuticle is known as cuticular transpiration. After stomatal transpiration, cuticular transpiration, there is a small third one, that is lenticular transpiration. The openings present on the older stems are known as lenticels, and the kind of water loss through these openings, these lenticels, is known as lenticular transpiration. Nearly 1% of the total loss of water in a plant takes place through lenticular transpiration. Approximately 90% of transpiration through stomatal transpiration, 5 to 10% through cuticular, maybe around 1% through lenticular transpiration. Now, what is the importance of transpiration crop plant? Dissipation of radiant energy by plants is a function of transpiration. Translocation of water in the plants is again a function of transpiration. Of course, translocation of minerals in the plants is also a function of transpiration on crop plants. So this is the importance of transpiration on crop plants. Like factors affecting the evaporation, there are some factors affecting the transpiration. Here also, like factors affecting the evaporation, the first one is environmental factors, the second one is plant factors here. Now, what are the factors affecting the transpiration? Environmental factors, plant factors. Of course, the first one among the environmental factors is light, Light, 0.4 to 0.7 microns in the solar spectrum. I told it has 41% of energy. Try to recollect. Now, light plays predominant role in transpiration, both directly and indirectly. The direct effect of light is on the opening and closing of stomata. Bright light is the main stimulus which causes stomata to open. It is because of this reason that all plants show a daily periodicity of transpiration rate. The indirect effect of light is that the increasing light intensity raises the temperature of the leaf cells. This increases the rate at which liquid water is transformed into vapor. So this is the first environment factor, light. The second one is atmospheric humidity. The rate of transpiration is almost inversely proportional to atmospheric humidity. The rate of transpiration is inversely proportional, almost inversely proportional to atmospheric humidity. The rate of transpiration is greatly reduced when atmospheric humidity is, of course, atmosphere is very humid. However, as the air becomes dry, the rate of transpiration also increases proportionately. These effects occur in accordance with the law of simple diffusion. Okay. So this is how atmospheric humidity influences the transpiration. As I said in the humidity chapter, as far as croplands are concerned, humid areas require less irrigation water. It is because the rate of transpiration is inversely proportional to atmospheric humidity. So there is more humidity in humid areas, so water requirement is less. That is the scientific reason that you must know in the basics. The third environmental factor is air temperature. Increase in the temperature results in opening of stomata. Temperature has significant effect on the permeability of the wall of the God cells and therefore greatly affect the osmotic phenomena. This phenomena is responsible for the movement of God cells. So, air temperature, increase in the air temperature results in opening of stomata. Therefore, the temperature has significant effect on the permeability of the wall of the God cells and therefore greatly affect the osmotic phenomena. This phenomena is responsible for the movement of the God cells. Now, the fourth environmental factor is wind velocity. The velocity of the wind affects the rate of transpiration to a larger extent or greater extent. Fast moving wind and air currents bring fresh and dry masses of air in contact with the leaf surfaces. So, Higher the wind speed, higher the transpiration. Like higher the air temperature, higher the transpiration. Higher the humidity, lower the transpiration. Like this, the environmental factors influence the transpiration. There are two important factors, as I said from the beginning: environmental factors, plant factors. Let us discuss plant factors. Among them, the plant height, leaf characteristics, and availability of water to the plant are important. Plant height. The water need of a crop varies with its height. In general, the rate of transpiration of a tall crop will be more than when the crop is cut or clipped to half. Okay? Greater the plant height, greater the transpiration. More the plant height, more the transpiration. Then second plant factor is the leaf characteristics. In some plants like cacti and other desert plants, the leaves of these plants are altogether almost, for these cacti and for some of the desert plants, almost, okay, leaves are absent and their functions are taken up by the stem itself. Of course, in case of pines, firs, etc., the leaf size is very much reduced. In such cases, reduction in leaf area brings about reduction in transpiration. Some Gramineaceae families like maize, okay, they flower, and some flowering plants, some cereals, some pulses, some oilseed crops. They roll up or turn the edges of their leaves when exposed to bright sun and fast breezes. This causes reduction in the transpiration. Just an example, whenever I take you to the field crops, I used to show, say around 10:30, 11 or 11:30, some of the leaves of groundnut crop. Okay, they tilt down. That means, upper surfaces are facing towards the ground, and the lower surface of the leaves you find. Why? It is because when the bright sun and the fast breezes occur, okay, most of the tomato for the leaves are on the lower side, so they tilt their leaves. Now, what is the availability of water to the plant? The third factor. If there is a little water in the soil, the tendency for dehydration of a leaf causes a stomatal closure and a consequent fall in transpiration. This situation occurs during periods of drought when the soil is frozen and at a temperature so low that water is not absorbed by roots. Simply, in the factors affecting the low air temperature plant injury, I told suffocation, physiological drought, heaving, killing, freezing. They are the same things I tried to explain. This is what is the availability of water to the plant. That means during the periods of drought and when the soil is frozen at a temperature so low that water is not absorbed by the roots, okay, the transpiration automatically and adjust to the situation. This is what we can say. Now, as far as the factors affecting the transpiration is concerned, first factors, environmental factors, in that the four are light, atmospheric humidity, air temperature and wind velocity. As far as plant factors are concerned, plant height. More the plant height, more the transpiration. Leaf characteristics, then availability of water to the plant. How I explain? If there is a little water in the soil, the tendency for dehydration of leaf causes stomatal closure and a consequent fall in transpiration. Where, under what situations this occurs? First, periods of drought. During the period of drought, when the soil is frozen and at temperatures so low that water is not absorbed by the roots. Then let's go to a very interesting, very simple, basic evaporation terminology. One, evapotranspiration from your examination point of view is also very important. What is evapotranspiration? Evapotranspiration denotes the quantity of water transpired by the plants plus the atmospheric moisture evaporated from the surface of the soil. Evaporation from the soil, transpiration from the leaves together is known as evapotranspiration. Then there is a term called as reference evapotranspiration. Sometimes the reference evapotranspiration is referred, sometimes, okay, as a product. When reference evapotranspiration and crop constant product is equal to, we call it as potential evapotranspiration. This, of course, I teach you in PG and PhD, that you don't worry. Just simple term, reference evapotranspiration, ET small o we call it as in our calculations. In the practical class also I try to give you something about this reference evapotranspiration, potential evapotranspiration, but to understand the basic evaporation terminology, okay, what is a reference evapotranspiration? Reference evapotranspiration, ETO, it represents the maximum rate of evapotranspiration from an extended surface of 8 to 15 centimeters tall green cover actively growing and completely shading the ground under limited supply of water. It is known as reference evapotranspiration. Then there is a term called as PET, potential evapotranspiration. The potential evapotranspiration for any crop is obtained from a reference evapotranspiration and crop factors and water supply is unlimited. Of course, in a very simple definition, PET is equal to crop constant into ETO or reference evapotranspiration. Of course, in my PG, in my PhD, and while working with innumerable teams of colleagues and my beloved students at PG and PhD level, I define myself potential evapotranspiration as the combined loss of this is from my side. I am convinced, and groups of my colleagues across globe with whom I worked, even in USA, even in Canada, or of course in Europe. Okay, my colleagues, scientist colleagues, have also accepted this definition by me for reference evapotranspiration and potential evapotranspiration. This is a basic class. I give my definition of potential evapotranspiration. Simple. What is that? The combined loss of water both from the soil and plant. Okay, when the crop is in its active growing stage, completely shading the ground under unlimited water supply conditions is known as potential evapotranspiration, PET. Of course, I am not deviating from the fundamental equation. PET is equal to Kc into ETO. That I am not deviating. As for a simple definition for the basic course like 103, Intro to Agrometeorology, Climate Change is concerned, I worked for several days or even months and found out this definition for potential evapotranspiration is good. The combined loss of water both from the soil and plant. Okay, when unlimited water supply is there and the crop is actively growing stage, completely shading the ground is known as potential evapotranspiration. Now, of course, like other weather elements, we also try to understand the importance of evapotranspiration or potential evapotranspiration for croplands. Really good. This is one of my favorite subjects for PG students and PhD students. And I also worked on evapotranspiration, potential evapotranspiration, reference crop evapotranspiration. I am convinced to state that the importance of evapotranspiration and potential evapotranspiration as far as crop plants are concerned, most important three, okay, the ways in which these are useful. One, in estimation of soil moisture, thereby planning irrigation schedule of any crop, understanding the relationship between the crop yield and irrigation water, guiding for the production of a crop with a fully developed canopy. For all these things, the studies on evaporation and transpiration, evapotranspiration, potential evapotranspiration, PET, crop constant into reference crop evapotranspiration. These are useful. Now, finally, what are the units of measurement of either evaporation or transpiration? Of course, evaporation is expressed in units of depth, that is millimeters or centimeters per day. It is expressed in units of depth, millimeters or centimeters per day. Thank you. May God bless you.